Here's a few powerful expressions that take some interesting approaches to create advanced functionality. If you've ever animated elements passing a camera in 3D space, you might have keyframed elements to fade in and out based on their position. In this situation, combining length and linear can be useful to automatically remap an opacity value based on this distance. In this composition, you'll see a number of star layers animating as a group toward the camera. Let's make their opacity fade as they travel towards the camera. So highlight the first star layer and hit T to open opacity. And you can add a new expression to the property. The first line will define the pixel distance values of the beginning and the end of the fade. So begin the first line with a variable, start fade, capital F, followed by an equal sign and a value of -1000, and then end the line with a semicolon. Now you can either go to the next line for this or stay on this one. I like to stay on the top one because it's an editable property, and create another variable called end fade. So end fade, capital F, follow this with an equal sign and a value of 4000, and end this line with a semicolon. On the next line, create a variable called cam, C-A-M, followed by an equal sign, and then write a reference to the current camera in the comp. This is going to start with this comp, capital C, period operator, active camera, capital C. Now follow this active camera attribute with a period operator, and then add a toWorld method. So toWorld, capital W, and then an open parenthesis, an open square bracket, and then 0, 0, 0, close square bracket, close parenthesis. This variable will calculate the current camera's position in relation to world space. So end this line and go to the next line and create a new variable for position. So I'm going to call it POS, followed by an equal sign. And then we're going to use another toWorld method. So toWorld, capital W, followed by an open parenthesis, and a reference to the current layer's anchor point. So anchor point, capital P, and then close parenthesis. End this line with a semicolon and move to the next line. And this line is going to calculate the distance between the camera and the current layer, starting with a variable, dst for distance, equal sign, and then the length method. Now after length, open parenthesis, and a reference to our active camera. So cam, comma, and then the second point is going to be a reference to the current layer's position, so POS, and then close parenthesis and semicolon. The final line will assemble everything with a linear method. So linear, open parenthesis, dst as the input, comma, start fade, capital F as the input min, and then end fade, capital F as the input max, comma, and then fade from 100, comma, to 0, close parenthesis. So this line is going to map this start fade and end fade input to 0 and 100 for the layer's opacity. So if you click outside of the expression field, you'll see that that star has disappeared because it's really far from the camera. But then if you RAM preview the scene, you'll see that the star fades in right there at the end. So now you can right-click opacity and copy expression only, and then select star 2 through star 12, and Control or Command V to paste, and now each of the star layers has the exact same expression applied. So if you RAM preview the scene, you'll see that each star, as it comes into the input and output range, fades from 0 to 100. Now just to finish the scene, you can right-click and copy the expression again, and go to Planet, and Control or Command V to paste, and now we'll have the planet fade in as well. But some of the values might need to change because it's a little further back. So I'm going to double tap E on the planet layer to open the expressed properties, click into the existing expression, and I'm going to change just the start fade and end fade ranges. So start fade needs to be about 6,000 because it's a little further back. End fade needs to change to about 15,000. Now because the planet doesn't go off screen on the edges and it actually rests in the middle, I'm going to also change the linear to an ease just to give it a nice smoother transition, and click outside of the expression. And so now if you RAM preview the scene, you'll see the planet comes slowly into view and fades in nicely. You may find yourself in need of a blinking cursor for a text field in After Effects that's receiving text input. Using some strings and a conditional statement, you can create a realistic typing effect with a simple slider. In this composition, you'll see a destination text layer. First thing you'll want to do is add a slider control, so Effect, Expression Controls, Slider Control. This slider will control a typing text reveal on the current layer. Now with the destination text layer selected in the timeline, rapidly tap UU to open up the source text property and add a new expression. Now on the first line, create a variable called src, followed by an equal sign, and then use the expression pick whip to grab the slider control. Now this will create a reference, and you can end this line with a semicolon. Now on the next line, create a new variable called blink, and follow this with an equal sign. And now you can use a Math.round method to count time. So start this with Math.round, capital M, followed by an open parenthesis, and then time divisible by 1, using a modulus operator, and then close parenthesis, and a semicolon. This variable will round the remainder of time divided by 1, and it gives you a steady looping output of 0 or 1 every half second, which is pretty close to the speed of a blinking cursor in a word processor. Now on the next line, create a variable called pipe, and then equal sign, open quotation, space, close quotation, semicolon. Now this is a blank text string placeholder for the pipe symbol when it's turned off. Now on the next line, begin a conditional statement with if, open parenthesis, another open parenthesis so we can nest a statement, and then reference blink, double equal sign, 1, close parenthesis. Now this statement is going to trigger every half second when blink is equal to 1, and then add a double pipe symbol. This symbol is usually found above the enter key, shift backslash, so the if statement is looking for either the first condition or the second condition. So the second condition is going to start with an open parenthesis and a reference to src, period, and then you can use the speed attribute. And then we want to see if this is greater than 0, close parenthesis. Now the second condition is checking to see if the typing speed of the characters is greater than 0. So basically if it's in the process of typing characters. Now we want to finish this entire condition, so you have to add another close parenthesis, and now an open curly bracket. And so here you can redefine pipe. So add another pipe variable, followed by an equal sign, and then open double quotation, pipe symbol, which is shift backslash, and then close double quotation, and then close curly bracket. So this condition statement says every half second or while the text is typing, show the pipe symbol. Otherwise, leave a blank space. Now on the final line, you can use a substring method to trim the text. So start with substr, open parenthesis, and the first value, which is going to be the start of the text layer, is going to be 0, comma, and then we want to trim to the number of characters specified in the slider control. So src, close parenthesis. And now after this, we can add pipe to the end. So this line is going to trim the characters to the specified value in source and then add the blinking pipe at the end. So now if you click away from the expression, you're not going to see anything, and that's because our slider's at 0. But the one thing that is working is the pipe symbol. About every 15 frames, it's appearing and then disappearing. So now all you have to do is animate the slider control. So I'm going to add a keyframe here at the beginning, and then I'm going to come forward to about 20 frames, and then you can click inside of the slider control value, and then I'm going to use the up and down arrow keys to start changing the value. So I want it to type out destination, colon, and I want it to pause for a little while. So then I'm going to come forward about another 20 frames, and then hit U so I can see the keyframes. I'm going to add another keyframe, and then come forward to about 2 seconds, and type out the rest. If you RAM preview the scene, you'll see that the text types out in 2 different phases. And as it types, the pipe is always visible. A cool expression to experiment with is fitting a dashed stroke perfectly around a circle based on a set number of dashes. Just a note, this only works on perfect circle ellipse shape layers on the stroke property. To set this up, you'll see a ring layer in the composition, and then come up to Effect, Expression Control, Slider Control. And let's go ahead and set the default value to 10 just so we can see something change later. The next thing you'll want to do is turn the layer on and twirl down the contents to find the ellipse shape. Now if you twirl down the properties, go into stroke, and then at the very bottom of stroke, you'll see this plus button next to the dash. And if you click it twice, it's going to add dash, gap, and offset. So on the dash property, add a new expression, and on the first line, create a variable called source, src. Follow this with an equal sign, and then pick whip the slider control on the layer. Now this is going to create a reference to it, and then end that line with a semicolon. On the next line, create a variable for the radius, so rad, follow that with an equal sign. Now for the radius, you want to pick whip the x value of the ellipse size property. So to do that, I'm going to click outside for a second. It's going to give me an error. And twirl down the ellipse path until you can see the size property. So I'm going to hit tilde so I can see this full screen. I'm going to come back into the expression, put my cursor right after radius, grab the pick whip, and come up and pick whip the ellipse path size. Now it's going to give us a reference to the ellipse path size 0, which is the x value. And then after this, I want to divide the entire value by 2. So this is the radius of the circle, or half the diameter. Now end this line with a semicolon. On the next line, create a variable called gap, G-A-P, and then follow this with an equal sign. And now you want to grab the expression pick whip and come down to the gap property directly under dash and let go to create a reference. And then end this line with a semicolon. On the next line, create a variable called segment, so SEG, followed by an equal sign. Now you can build a ternary operation to set the minimum number of segments on the stroke. Start this with a reference to source, and then less than equal to 0. Now add a ternary operator, which is a question mark, followed by a value of 1, and then a colon, and then another reference to source, src, and then end this with a semicolon. So this strange line of code is using a ternary operation to check if source is less than or equal to 0. If so, the number of segments is set to 1. Otherwise, segment is set to the slider control's value instead. It's basically a compact if-else statement that sets the default minimum number of segments. The final line is going to calculate the circumference, so start with 2 times math, capital M, period, pi, capital P and I, and then times radius, so RAD. So this is a basic circumference, 2 times pi times radius. And then after this, you want to divide the circumference by the number of segments. So divide by segments, SEG, and then finally minus gap. And that's going to subtract the gap length from the dash property. So now I'm going to click outside of the expression and hit tilde to collapse this back. Let's scroll down just a bit. And now you can see the ring has a set number of segments around the outside, which matches the slider control's value. If I change this to something like 50 and then click away, you'll now see there's 50 segments around the outside of the ring. I'm going to set this back to 10, and then I'm going to come down to the gap and change the length to something like 50 and click away. So now you see 10 segments specified in the slider control with a 50 pixel gap around the outside. So this is a lot of fun to play with already, but there's one more thing we can do to finalize the expression. This is going to include adding a new expression to the offset property. So add a new expression and grab the expression pick whip and pick whip the dash property containing the expression we just wrote. Now if you let go, it's going to create a reference, and then all you have to do is divide this by 2. Now if you click away from the expression, you'll see the segments have shifted just slightly, and now you have these segments lined up with each other. So if I scroll up here and change the stroke width to something a little more visible, like 20, and then scroll back down, I can change the gap and it's going to shrink these in real time. And I can also change the dash value and it just adds and subtracts as needed. Without these expressions, if I turn them off for a second and come up to the dash property and drag this slider around, you'll see that it clips as it comes around the outside, and that's because the dash and the gap currently have no way of knowing what the circumference of the circle is, so it can't evenly divide. And then we fix this slight offset problem here by adding a new expression to the offset property. And now everything's lined up, symmetrical, and easily modified. You can use JavaScript date objects to output and format a date in real time. So let's start and output the current date on a text layer. In the composition, you'll see a date layer, and it has some placeholder text, arrival date. So with the layer highlighted, rapidly tap UU to reveal the source text property. Add a new expression, and on the first line, create a variable, lowercase d, followed by an equal sign, and then we're going to create a JavaScript date object. So type new space date with a capital D, open parenthesis, and then another date with a capital D, another open parenthesis, 0, close parenthesis, semicolon. This is a JavaScript date object which will match the current system time on your computer, and we can use this as an anchor for all the other date components. Now on the second line, you can create a new variable called day, followed by an equal sign. This is going to be a custom array, and it's going to contain separate text strings with the name of each day of the week as indices, starting with Sunday. So first we want to open the array with an open square bracket, and then I'm going to create a text string. So open double quotation, Sunday, capital S, close double quotation, comma. Now follow this formatting and do the rest of the week. Open double quotation, Monday, capital M, close double quotation, comma. Tuesday, capital T, comma, Wednesday, capital W, comma, Thursday, capital T, comma, Friday, capital F, comma, and Saturday, capital S, and end this with a closed square bracket and a semicolon. So it's a lot of work, but we're basically just creating text strings for each of the days of the week. Now on the next line, you can format the calendar date starting with a variable called date. So date, lowercase, followed with an equal sign. And now let's start to work with the JavaScript date object. So I'm going to reference it with a lowercase d, and then a period operator. And let's go ahead and retrieve the month. So get month, capital M, and then you want to include an open parenthesis and a close parenthesis. Now because months are 0 index, month 1 is actually going to be 0. So in order to fix this, you can just add a 1 to the end of this. And this is going to retrieve the calendar month in 0 index format and then add 1 to it. So after this, add a plus, and then we're going to add a text string. So open double quotation, / close double quotation. This / is going to separate the month from the day. So now after that, add a plus, and then we're going to use the date object again to get the calendar day of the month. So lowercase d, period operator, get date, capital D, and then open and close parenthesis. After this, you can add another /, so plus, open double quotation, / close double quotation, and then another plus. And finally, we're going to get the year. So this is going to use the date object again. So lowercase d, period operator, and then get full, capital F, year, capital Y. And then follow this with an open parenthesis and a close parenthesis, and then end this line with a semicolon. So that was a pretty tedious way to get the date, but we have the month, the day, and the year outputting. And now you can move to the next line. We're going to assemble everything together. So start with a reference to the day array from earlier. So day, open square bracket, and then we're going to grab the day's index. So D, period operator, get day, capital D, open and close parenthesis. And you can close this with a square bracket. So essentially, this is going to look at the day array and grab the text string associated with the current day's index. So after this, add an addition operator, and then add a text string with a comma. So open double quotation, comma, space, close double quotation. And now that we have the day of the week, let's go ahead and grab the date. So plus date. Now, if you click away from the expression field, you should get a nicely formatted date that matches the current day of the week and the calendar month, date, and year on your computer. We've arrived at the end of lesson 402, an in-depth look at powerful advanced expressions. If you enjoy this expressions course, consider purchasing the paid content. It includes in-depth documentation, extra tutorial content, high-definition videos, and all the project files used in the training. Your purchase will help to create more free courses like this in the future.